Everyone, I am Hoshal Rajendran. Today we are going to talk about a special kind of machine learning concept called ensemble technique. So here we are specially focusing about the stacking technique. So there are many ensembling techniques like bagging, boosting, stacking, and one of the easiest concept among those techniques is stacking. So now we are going to take a look about what is meant by stacking. Before seeing about stacking based algorithm for ensembling techniques, uh, it's better to think about what's meant by ensembling and what's the difference between the ensemble techniques and simple machine learning based model techniques like that. So see here you can see uh, in the in this part of the slide. So I have listed some machine learning models. So simple models. So these are simple models. Simple models means that they are they are the only one algorithm to solve a particular problem. So here for this machine learning algorithm, so it can be any one of these. So it's only one algorithm. It can be either logistic regression, decision tree. It can be anything from this list. So but it's only one algorithm. So that algorithm will be trained on a training data set, and then it will be it can be used to for a classification on an unseen data. So that's the core idea of the machine learning. So these are the simple models. Simple models mean it's having only one algorithm. But the difference here is the difference between the ensemble technique and simple model based technique is ensembling means here we have multiple models. So here we may have for example in the ensembling technique we may have for example three models like logistic regression, decision trees, and support vectors. So we are having three models, and those three models also will provide an output, so which is correct, so which output from the model is correct. So that's the part that we have to figure out. So uh, in that case we are going to um, design another small another algorithm that can obtain the inputs from these trained models and decide on its own which is the correct output. So the task of that algorithm is to return the correct output based on the input that are being obtained from these trained models. So in our example case, we said like decision tree, support vectors, and logistic regression like that. So that's the difference between the simple models and the ensemble based techniques. Ensembling means that it's a technique that combines the prediction of multiple models. So it's more than one model to produce more accurate prediction. And also it outperforms in than the single models. So in some of the machine learning problems, not all the machine learning problems, but in some of the machine learning problems, it has been seen that this machine learning approach, ensemble based approach, is outperforming the simple machine learning based models. So that's the importance of the ensembling. So it has so as I said previous, so there are many ensembling techniques, for example stacking, bagging, boosting, like that. So these are the no, typical ensembling techniques. But in addition to that one, there are in previous years they have also developed weighted average based or average based ensembling as well. So we will take a quick look about the previous traditional approach as well as the stacking, bagging, boosting as well. So here it's what's meant by the ensembling is that we are going to use multiple models to arrive at a particular one decision. So next we will look about the what's meant by the ensembling by the combination function. So ensembling can be done in many ways. So as I said previously, there are stacking, bagging, boosting. Those are the techniques. But in addition to those techniques, there are also some kind of a, different approach that were used in the earlier period of machine learning. So I think it's better to take a look about us to have some idea about that kind of a concept also. So this is a machine learning ensembling by combination function. So here we are going to use a combination function as the decision function. So that's the decision maker. So it will takes the input from the uh, individual machine learning algorithm. So we will look at these things from the beginning. So here the initial part is the data. So data is sampled. So for example, if there is a data set like this, um, so it's sampled like this. So there it's a uh, so it has some okay 100 data points. So we assume that we have sampled it by three different samples. Okay. So then the first sample will be assigned to this algorithm 1, second sample will be assigned to algorithm 2, and third sample is assigned to algorithm 3. And so there are three different machine learning algorithms we have used: decision tree, nearest neighbors, and naive bayes. And these algorithms are trained based on this sample. And after the training of these algorithms, then we are going to get the output of these algorithms like y1, y2, and y3. And then we are designing a function. It's a function that is based on the output of these three algorithms. So that function may be a kind of a priority function. So it's based on the results of the uh, algorithms that output of the it's based on the outputs that the algorithms are producing. So for example, for most of the problems, machine decision tree is providing good results, and second, naive bayes is producing good results, and third, this one is producing good results. Mean we are kind of a weighting function. So we are assigning more weight to this decision tree, and then less weight to naive bayes, and even less weight to uh, nearest neighbor. But it depends on the class also. In some classes, for if there are four classes, so in some class decision tree for the first class, for example, for if I take, there are four classes like birds, amphibians, reptiles, and insects. So if there are four classes, so in the amphibian class the decision tree is performing well, and in the reptile class naive bayes is performing well, and the insect class nearest neighbor is performing well. So based on, so we have to do a detailed analysis, and so which class which algorithm is performing well, so which class so in this class this algorithm is performing. So we have to train the model, and we have to get the confusion matrix of the model, and we have to do a detailed analysis on identifying so which model is performing well in which class. And based on those decisions, we are going to make a combination function. So that gets the input from these models. So output of these models will be the input to the decision function, combination function, and that function is capable of identifying. So it can be a mathematical function or a rule based function. So it the purpose of this function is to um, correctly do the classification to make the accuracy higher. So that's the ultimate goal of this combination function. So for that one, mm, we have to carefully design this combination function based on the thorough analysis of these individual models. After that, we will be able to design a combination function. It can be a mathematical function or a rule base. And after that one, when we are providing a new data point, that will be gone through the, then if we are providing a new data points, there is no need for sampling. So after that one, it will be gone through this first algorithm and second algorithm and also third algorithm, and their output will be obtained. Y1, Y2, Y3 will be obtained, and that Y1, Y2, Y3 will be directed to this combination function. It will provide a certain output. So it's a straightforward approach. There is nothing new or nothing uh, different part here. So we are getting the output from the three models and we are doing a thorough analysis. So that will be the difficult part. So it's our responsibility to do a thorough detailed analysis about these machine learning models and which are performing well, and to kind of an identifying a correct rule base that can provide a correct output. So that's our duty to design such kind of a combination function.